Welcome to your Hess's Law pre-lab. If you'll listen carefully to these instructions and follow these tips, your lab is going to go a lot smoother and your results will be better. So pay careful attention to what comes next. So you've seen a lot of this before. You're going to be using a balance and a computer and a hot plate. A few special new items here. A coffee cup calorimeter is, well, two coffee cups nested together with a styrofoam plug that goes in the top. They do a surprisingly good job. We'll show you how this works. You're going to have a stir bar. We're going to explain that in a minute. And a stir bar retriever. That's the little pipette with that white object in the tip of it. And since you've already watched the Logger Pro pre-lab, you know about the thermistor, the Go link, and the last tool to the right is the thermistor clamp. We're going to take a quick look at the insides of a magnetic hot plate stirrer and a stir bar. So here's an exploded view of your hot plate. This is clever. You've got a motor with a magnet on it. The motor spins the magnet. The magnet spins anything metal or magnetic that's on top of the plate. And then off to our right here is a close-up of our little stir bar. So Heather's going to demonstrate how this works. Remember, we're not using heat in this experiment. Don't turn the heat on ever. This will work through a couple, 3 inches of space, and it works just fine within those little styrofoam cups. So now we're going to look at our dry reagents. You've got magnesium oxide. You've got magnesium turnings. You will have individual samples provided for you at your stations along with scoops to work them with. Our single liquid reagent is 6 molar hydrochloric acid. Read the following carefully. These hazards are to be taken seriously. The hydrochloric acid is an especially immediate danger. Don't get this on your skin. If you do, wash it immediately. So now we're going to show you how to dilute acids safely. There's no one right way in terms of the equipment you use, but there's a best way to use the equipment that we have given you. So please follow this very, very carefully. There is one cardinal rule for diluting an acid. Acid added to water. Do as you oughta, add acid to water. So these are our acid handling tools. The graduated cylinder, you'll get that at your station. And then you're going to have a Phillips beaker. You saw those with the hydroxide in the titration lab. And then we're just going to have some simple pipettes in an Erlenmeyer flask. Now Heather is going to demonstrate dilution. She's got her tools all up in a row. Now, our Phillips beaker right now is empty, and she's going to add a little bit of acid to it. When you get to it, you probably won't have to do this. If you do have to do it, that's fine. And if you're uncomfortable doing it, you can ask for help. You don't need much, never more than maybe half at the most. So she's put more than enough in there for our one demonstration. Now she's going to go for the water. She's just going to squirt water in the cylinder until she gets a known amount. She's picked 50 milliliters. She's going to get that amount as exactly as she can, and she's going to make sure of that exact amount, carefully verifying it by eye. Now, I want to emphasize something. You can fill your cylinder with water outside of the hood, do it at your station. You can even bring your water bottle to the hood if it'll make things go faster. And you don't have to squirt the water. You can take the cap off of your bottle and pour. But what you cannot, absolutely cannot do here is take the 6 molar acid out of the hood. That stays in the hood. You use it in the hood. You dilute it in the hood. You can take your 1 molar back with you, but leave the concentrated material in its place. So Heather has now verified her mark, how much water she has. And she's going to take her acid from the Phillips beaker and she's going to carefully pour the amount she has calculated needs into the graduated cylinder using the graduated cylinder's hash marks to measure the acid. When she gets close, now Heather is going to switch to a pipette, and she's going to add acid dropwise until she gets to the level that she believes is correct. She's going to hold this up. Be careful when you do this so that she gets an eye-level view of the meninsis. You'll be able to see the two solutions mix. And once she gets there, she's going to use the water bottle, squirt bottle this time, and she's going to fill it up to the 100 milliliter mark and carefully verify that. And there's our solution. Now this is important. Acid spills are neutralized with sodium bicarbonate. There are bicarbonate bottles all over the lab. There will be bicarbonate bottles in the hood. You simply apply the bicarbonate until the fizzing stops. You can blot it up with paper towels and make sure you inform your instructor. So now we're going to set up the calorimeter. Watch this very closely. So the first step in setting up the calorimeter is doing a kind of dummy run and making sure everything lines up. So Heather's going to put her two pieces together, and she's going to put her stir bean in the bottom of the inner cup. Now she's going to take the thermistor clamp. She's going to put it on the rod that supports it. She's going to add the thermistor. And then she is going to verify that when she drops the thermistor down into the cup, she has it aligned to the right depth. It has to be in the solution, but of course it can't hit the bottom. It has to be in the solution and above the magnet and not hitting the bottom. So she's going to make sure visually that she has it lined up correctly, and then she's going to add tape to the standing part so that she knows how far down to move the clamp. She's going to move it back out of the way now. Add the top. And make sure that the horizontal XY positions are correct as well. The depth has to be right, and the alignment on the hot plate has to be right. Now she's going to put tape on the hot plate. Remember, we're not using heat, so she can do that. And she's going to use the tape to mark where the cup goes. This will save you a lot of time. Once you have figured out how this all lines up, you'll never have to fix it again. So here's a view from the top. This is what you need to see when you have your tape all placed and everything's lined up. Please note, the cup needs to be more or less centered on the hot plate so that the stir bar will spin smoothly. Probe just above the stir bean, not into the bottom. And this is why we are so careful. You only get to make this mistake once. These cups are very fragile. A probe will go right through them. After you clean up, you get to start over.